One day, John Park decides to visit Stetson East to bond with his fundy students. There's a 45% chance that he eats the chicken, a 35% chance he eats the fish, and a 10% chance he goes vegetarian and chooses tofu. 20% of the chicken is undercooked, meaning eating it will result in food poisoning. 69% of the fish contains salmonella, resulting in tummy troubles for anyone who eats it. Professor Strange is feeling evil today. She decides to sprinkle 30% of the tofu with a non-lethal poison. Question 1. What is the probability that Professor Park eats chicken and gets sick? Question 2. What is the probability that Professor Park will get sick? Question 3. Suppose you see John Park leaving steast looking young and spry, aka not sick. What's the probability that he ate tofu? Adventures at Steast. Solutions. So before we get started, we want to define some general definitions. So for these solutions, we're going to define the following events. C, the food is chicken. F, the food is fish. T, the food is tofu. And S, John Park gets sick. What is the probability that Professor Park eats chicken and gets sick? So in this problem, we're looking for the probability of C and S. This is the same as the probability of chicken, or C, times the probability of S given C, by the definition of conditional. Using the values from the problem, we get 0.45 times 0.2, which is equal to 0.09. That means that there's a 9% chance that Professor Park eats chicken and gets sick. What is the probability that Professor Park will get sick? So we're looking for the probability of S. Now there are 3 ways John Park can get sick. Either he gets sick from the chicken, the fish, or the tofu. In other words, the probability of S is equal to the probability of C and S, the probability of F and S, and the probability of T and S. We can then use the definition of conditional to rewrite this statement as the probability of C times the probability of S given C, plus the probability of F times the probability of S given F, plus the probability of T times the probability of S given T. Now when we substitute in the corresponding values, we get 0.45 times 0.2 plus 0.35 times 0.69 plus 0.1 times 0.3. This gives us our final value of 0.3615, which means that there's a 36.15% chance that Professor Park will get sick from going to steast.
Suppose you see John Park leaving steast looking young and spry. What is the probability that he ate the tofu? Well, to figure this out, we can use Bayes' formula, right? We can figure out the probability of tofu given not sick is also equivalent to the probability of tofu times probability of not sick given tofu divided by the probability of not sick. And to figure out the probability of not sick, it is also equal to 1 minus the probability of getting sick. So the only other thing we need to figure out is the probability of not sick given tofu. So to figure out the first one, where the probability of not sick, we just use 1 minus the probability of sick, and eventually we'll get the answer 0.6385. And we also know that the probability of tofu is 0.1. We know this because John Park picks the tofu 10% of the time. And the probability of sick given tofu is 0.3, because we know that 30% of the tofu has a non-lethal poison in it. The probability of tofu is also equal to the probability of tofu given sick, or tofu and sick, plus the probability of tofu and not sick. We need to use this actually to figure out this right here, the probability of not sick given tofu. And if we write this all out, we get this equation right here, which has the probability we need. And all of these are actually able to be substituted in because of the information we already know. Once you substitute it in and you divide where you can, you figure out that 1 is also equal to 0.3 plus the probability of not sick given tofu. And then eventually you figure out is the probability of tofu. And then you plug it all in and you can figure out that John Park, given that he's not sick, has a 10.9% chance of eating tofu that day.